Tonight's questions are going to be based around trig identities. So let's just go over the basic ideas. Probably the most important basic trig identity that we spoke about in the last lesson is that one. But that one can also be rewritten in two ways. You can write it as that. Sorry, my handwriting is getting a bit dodgy. So 1 minus, let's rewrite that. 1 minus cos squared x. And then over here, we can write it as cos squared x equals 1 minus sine squared x. So those are two different ways of writing the square identity. And then we also have what's called the quotient identity, which is that one. And so, yeah, just give me a thumbs up if those all look familiar and you're starting to become better friends with those two identities. Let me see if you're familiar with those and they're becoming better friends. You're becoming better friends with those identities. Then you also have like reduction formula identities, which I don't know if we'll do today, but we've done in previous lessons. So if I say to you, like, what is the sine of 180 plus x? Using reduction formula, you can work out that that's minus sine x. Or if I say to you, what is the cos of 180 minus x? That would be the same as minus cos x. So that's called the reduction formula. And then, so that's an identity that you need to be aware of. And then there's also things called co-ratios. So if I say to you the cos of 90 minus x, I'd like you guys to put this in the chat. What do you think the cos of 90 minus x is the same as? We covered this on earlier videos, but it's always good to check. So yeah, this would be the same as sine x. And what if I said to you, what is the sine of 270 plus x? What about that one? What would that reduce to using co-ratios? Could you do that one? So think about what quadrant you're in. It's often helpful to have so 270 plus x. So the triangle is actually being formed with the vertical axis. So in that quadrant, sine is negative. How far away is it from the vertical axis? It's x away, but you have to change it to its co-ratio. So this will be minus cos x. Okay, so be careful because you are using the vertical axes. You'll notice that we're changing from cos to sine or sine to cos. We change to the co-ratios. And that doesn't come up as often. It's much more common to have these ones, but it's just something to be aware of going forward. So that's why I like to recap. All right, so let's go to the main focus of today, which are proving questions like this one. And I think we actually covered this in the last lesson, but let's just start with it just to refresh. So how do these questions work? Well, you have to prove that this is equal to this. The common technique is to choose the harder side. So this is the harder side, and you work with it, and it's called the left-hand side. So you say the left-hand side is equal to this. But you need to now work with this left-hand side to make it equivalent to the right-hand side, and then you are considered to have proved it. So where should I start with my steps for this one? Using the identities that you know about and bearing in mind the promised land is 1 over cos x, where should I start? I want to get to 1 over cos x. Where's your attention being drawn to? Yeah, my attention is also being drawn to the tan x. And so I think we should replace the tan x with sin x over cos x. But we have another problem. I need to glue these two things together. At the moment, they're separate, and at the end, I have 1 over cos x. So I know that sin x times sin x is sin squared x. So that's nice. I know that that's cos x. If I want to force this to be a fraction, I can put it over 1. But now I'm still stuck. I need to glue these together. But I want suggestions from the class. What do I need to do to allow two fractions to be added together? I think they need to have the same denominator. So at the moment, cos x is the denominator here, but I need to force this one to have the same denominator. So I'm going to ask you, I'm going to times the top and bottom by the same thing, something in the red box. What am I going to put in the red box? What do you think goes in the red box? What do you think goes in the red box? It has to be cos x because that's the only way I have denominators that are the same. So I have sine squared x over cos x plus, now what's this times this? It's cos squared x over cos x. And oh my goodness, this is a glorious day because now I can add these two things together. But I'm still not at 1 over cos x. What do I still have to recognize? I feel like I've seen the stuff. Yes, let's go. I see your hand is up there. Siem Tanda, what do you think we should do?
Can you hear me, sir?
Loud and clear.
So basically sin squared x plus cos squared x changes into 1, so it becomes 1 over cos x.
And that's exactly what we were hoping for. Perfect. And then all you do is you just say is equal to the right-hand side, and then you're golden.
Thank you.
Fantastic. Okay, now, as we go to doing these harder trig identity questions, there's a couple of extra tricks I want to tell you about. So these are little steps, little mathematical steps that you would have learned about in the past, but you may have forgotten them. And so I just want to remind you why they work before we take on these slightly harder ones. Okay, idea number 1 is if I have to change a number like 1 into a trig ratio, as long as you write the same thing on the top and the bottom, it doesn't matter what you write, it's still going to be 1. So this is a very common trick where you give it a number and you need to change it into a trig ratio. And this idea works for other numbers too. Like if you had the number 2 here instead of 1, you would just put a 2 over here, and over here, and it would still be equal to 2. So that's a common idea. The other idea that we saw now is that if you have two fractions and you need to add them together, so let me make up an example now. Like if you have 1 over cos x plus, let's say 1 over cos squared x plus 1. And now I need to add these two things together. What you would do to start with is you would force the 1 into the form that you want. Okay, so that's great because your denominators are the same. And then what you would do is you would say, well, look, this is the same denominator. So now on the top, I get that. So that is a common idea. And then just one more other one that does come up, and you'll see them in the steps that we do, is if you have like 1 over sine x over cos x. So basically you have a number and you are dividing by a fraction. There is something called tip and times for fractions. So you could rewrite this as 1 times cos x over sine x. You've just tipped these two fractions over, and what that means is that it's a bit easier to deal with. And so that's another common one. And then there might be some other ones like, oh, factorizing. So you also need to know, like, if I say to you, this is sine squared x plus sine x cos x, if I wanted to factorize this, the common factor would be sine x. What do you think would go inside the bracket? Let me know what you think would go inside the bracket there if I was factorizing that trig expression. So I think it would be sine x, because there was 2 of those here, plus it would be cos x. Because think about this. This says over here, the green one, let me just move it up. If I look at this, if this was written out the long way, it would be written out like that. What do both of these have in common? They have a sine x here and a sine x here. So that is the sine x that's over there. Then what's left behind? Well, there's the sine x, which is the blue one. And then let's say this one over here is the cos x, that's the green one. So I've just shown you a whole bunch of little mathematical, I won't say tricks, but mathematical ideas that you often need to use. Give me a score out of 10 about how clear these ideas are for you. So give me a score out of 10 about how clear these ideas are for you. Whereas 10 is perfect, 0 is nothing, 5 is somewhere in the middle. Do these ideas make sense to you? Because they're going to come up in the lesson later today. Okay. So you'll notice them in the lesson, so you'll see that your understanding will improve with time. But for now, you just need to be exposed to them. Okay, let us take on number 2. So I'm going to put number 2 up, and I want to start for our first choice. Which side should we start with? Which side should we start with? Who feels like they know which side they would start with? For me, I'm going towards the left-hand side because it just looks more messy. So now I have a choice. What should I do with the left-hand side? Where would your first step be in that these have to interact in some way? But multiplying out seems very difficult. What could I maybe play with or substitute to get me going? I agree, Siamtanda. Siamtanda said, why don't I change the tan x to this? And I agree. And you know what? I'm not going to touch this one over here. I'm going to leave it exactly as it is because there's no obvious way to deal with the blue bit. Okay, thanks, Simtanda. And now, what do you think we should do next? And again, you don't have to have a perfect idea, but what do you think we should do next? I still think multiplying out would make a big mess. Does anybody have a trick or an idea they could use that might be worth exploring? I'll give you a hint. What do you think I'm putting it over 1 for? Yes, Rolani, you're going to make this the same denominator. What do I need to times the top and bottom by to make the same denominator? What is the amount? I'll put it here as a mystery black box. I know I need to times by something. Well, of course, it has to be the thing that is there already. So we have cos x, cos x. So let's see what we get. We get cos x times sine x. And this is going to be over cos x plus sine x over cos x. And that's good news because we forced the denominators to be the same. I'm going to put this in a different color just so that it doesn't worry us too much. Okay, now I think we can all see what is coming next. I'm going to put them together because we wanted the denominators to be the same. And now we have the same denominator. So let's do that. Let's say that we get cos x times sine x plus sine x over cos x, where the cos x was that lovely denominator that we made. Okay, now the red bit hasn't changed at all. So that is just staying where it is. I have a feeling that the action is all going to be in this top bracket here because it's the messiest. It almost feels like that's where we need to clean something up. But what I'd really like to be able to do is cancel some stuff out. At the moment, there's no factors that could cancel. Who has an idea about what we could do with the green stuff? Who has an idea about what we could do with the green? Yes, it's realizing that there's actually a common factor there. And that common factor is sine x. So what will go inside that bracket? And we're going to leave the red one as it is. It's just going to be. So what is going to go inside the bracket? Well, I took the sine x, so it's going to be cos x. That's this bit. Now, how do I get? Oh, I just put plus 1. Ooh, this is good news. This is very good news because I think that that is cos x. That's a bit dark. Let's undo that. I think that that is cos x plus 1. And that's 1 plus cos x, but it's the same thing. So what do you think I'm going to do with those two yellow bits there? Cancel out. Exactly. All right. Now, we canceled out. Now, remember, we're trying to get to the top line. Now we have sine x times sine x over cos x. What is my final step? If I look at the top about where I'm going, I've already got a sine x there. What is the final thing that I need to realize? What is the final thing that I need to realize? I think that this is an identity which I've seen before. And in fact, that sine x over cos x is just tan x. And so really, I've run out of space, so let me just write it here. Sine x times tan x. This thing is tan x, which is equal to the right-hand side. Oh my goodness, what a journey. So let's have a look at the key steps. Let's review the key ideas that we used in this question. So step one was to translate the tan into sine x over cos x. Step two was to make denominators that were the same and put them together. Step three was to factorize this. Step four was to cancel. Step five was to recognize that this was tan x. Quite a tough one, but you know, if you want to get an A for maths, this is the sort of question that you want to get comfortable with. So give me a score out of 10 about how much you understood that question. 10 is perfect, 0 is nothing, 5 is reasonable. Where do you put your understanding of this example now that we've been through it? And are there any questions or comments that you would like to ask? Okay, so I think we just need to practice more of these, but I think you are seeing some of the patterns come up again and again. All right, well, let's do this. Let's say, let's start with number 3. We may not have enough time. We may not have enough time to do, or maybe we should do this one. I don't think we've done this. Let's do a slightly easier one. Okay. I want you to show me that this one is equal to that side. What side would you start with? With this one? Would you start with the left-hand side or the right-hand side? I'd start with the left-hand side too. Okay, I'm going to give you some time to start this by yourself. I want you to tell me stuck when you're stuck or done when you're done. So I want you to try and do this by yourself to start with, and then I will get involved once I see enough stucks in the chat. Take out your pen and paper and see how far you can get with this one. And I agree, starting with that on the left-hand side is a good one. Good idea. Where would you start with this one? And put some hints in the chat if you're feeling generous. I'll give you a little tip. My attention is being drawn to that. Who can give us a connection between, where have you seen this before? Where have you seen that? It's ringing a bell for me. Yes. So Sange has recognized that this actually is the same as cos squared x. So if I rewrite the top one, I don't recognize. It's sort of recognize it, but like not that much. But this, that I can recognize. Okay, now this is another one of those fraction things that is so sneaky, but once you see it, you see it. Who has an idea? I want to open this to the floor. How can we go from here and try and make it look more like that? There's one important step. It's almost like common denominators in reverse. Okay. Ask yourself this. Is there anything wrong? Oh, Rulani, let's go to you. Rulani, what do you think? What idea do you have about the red circled bit?
So I was guessing we could break up the bracket so it could be sin squared x over cos squared x minus
Yes,
cos squared x.
that's exactly what I was thinking. So it's almost like I'm using common denominators in reverse. So think about this. Earlier on in the lesson, we were building our own common denominators, especially so we could stick things together. But the problem is, if you look at where we're trying to get to, things are split. So it would be a good idea if I could split things apart. Now, if I do that, things get very nice very quickly. So what are you noticing once I split that? Who has some ideas about what they... Yeah, Rolani, what do you see?
It's going to be the sin squared x and the
Yeah.
fraction of the one.
So this bit is going to be tan squared x, and then anything over itself is 1. So that's that trick I was talking about earlier on, where anything over itself is 1. And oh my goodness, we are done. So you can see these ideas, like it seems like common denominators, replacing a 1 with the same thing over itself. These are common ideas that come up quite a lot. And you do have to practice these. So I will put some practice material in the Google Classroom. What I'm trying to do is just build a base with you so that you feel like, okay, I know which staircase to climb. Is that a question, Rolani? Do you have a question you want to ask, or is that just your hand still up from earlier on?
So
Okay,
the question,
good. Oh, question,
I'm
go for it.
asking for the oh, I'm asking for the numerator when it's still in the question form. What if you put the sin and cos into one bracket also of 2?
Okay.
Is
I
that
didn't
wrong?
quite get that, Rolani, because your line is a bit break up. So maybe what we can do is we're going to quickly do a halftime break, and then we'll come back after the break, and maybe your line will be a little bit clearer. But just for every reason, I couldn't hear it very clearly there, the question. Okay, let's take a break. Let's take a break quickly for a brain break, because we've been pushing quite hard. So I want everyone to turn on their cameras and join me in just a little bit of a unwind as we we just power up for the second half. We know that it's hard to do a full hour of maths, especially on day one. Our bodies need some help. So let's start with some nice deep breaths. Breathe in. Breathe in. One more last deep breath. Okay, let's shake out our arms. I know this feels weird, but it's just so good to loosen you up. Shake out your legs. So you just want to get that circulation going. Okay, and then let's roll our shoulders. Roll them back. Roll them forward. Let's do some tricep stretches. We haven't done these for a while. So tricep stretch. And then another tricep stretch on this side. Okay. Oh, that felt good. Circles. Your arms going forward, going back, and shake them out one more time. Shake out the legs. Oh, I can feel myself relaxing, which feels good. Okay, we've had some oxygen, we've had some loosening up. Now it's time for some blood flow. Jumping jacks, which go like this. And we are going to do 15 of them. So make sure the space around you is clear. You're not going to whack anyone or anything. And let's go. 2, 3, 4, 6, 7, 10, 11, 12, 13, 14, 15. And that is it. So let me know how you are feeling in the chat. How is your concentration feeling out of 10? Let me know. And then it's been a while since we've done one of these. So here is your fun puzzle for today. What is a cat plus a pig plus a horse equal to? Can you figure that out? Okay, so cat is 10. Yes, cat is 10 because that's the only way that that would be 30. What is a little piggy going to be? I feel like the piggy has to be 16 because that's 32 minus 10. Yep. What is a horse going to be? It does indeed, Stephen. It has to be 5. So now, what is my final answer? What is my final answer? Well, there's no BODMAS issues here. It's just 10 plus 16, which is 26, plus 5 is 30. Is that 16? No, it's 16. So 10 plus 16 plus 5, I think the final answer should be 31. Okay. So that's just a set of simultaneous equations, really, but just in pictorial form. So I agree, Stevens, and Simtanda agree. So we can be pretty confident we've got that one. Okay, we're just going to do 15 more minutes of trig identities because I know these are a bit taxing. Let us see what selection. Should I choose number 4 or should I choose from here? Let's have a look. Let's choose from here. I'm going to choose C. So these are different types, but I want you to try by yourself to do C. So off we go. If you get stuck, tell me in the chat that you're stuck, but let's see how it goes here. Let's try and do C. And if you're feeling generous, tell us in the chat where you would start. Okay, I think I would definitely start with the left-hand side. So that's my one tip to you. So why don't you start with the left-hand side and then see where life takes you from there. Maybe just put a step. Give us a hint. I know some of you really do know this well. Where would you start now? What's the problem if I want to get to, I call it the promised land, but it's like the right-hand side, right? I want to get to cos theta. If you look at what you've got here, what would be so helpful if you could do something? I was just wishing that the denominators were the same. If only there was a way I could make these denominators the same. So, yeah, if you're done, say done. If you stuck, say stuck. Okay. What should we do? That's my hint. What should we do next? I think I like that. Yeah, I've times the top and bottom by cos theta, so that's the same as 1. And then there were 2 cos thetas. And so those 2 together give us this. Ooh, yes. So we could change the tan squared theta into sine squared theta over cos squared theta. But I was thinking before we do that, can't we just put them together as well? So we get like, it's all over cos theta, and then I have 1 minus cos squared theta. Oh, okay, I see what you mean. And so now I think I can replace the tan squared theta with something. Let's use a different color. So I think this is sine squared theta over cos squared theta. Ooh, I like that. What can I do now? And the other thing is that this can always be written over 1. So what should I do now? Thanks for that, Sange, because Sange gave us that good tip that I could change this into basically this. But what's my next step going to be? Yep. These are going to cancel out. And now I'm left with 1 minus sine squared theta over cos theta. Now, I'm not there yet, but I'm getting close. What is my next step going to be? So this is looking familiar over here. So I think cos squared theta over cos theta. And now, what do we have? Well, actually, that can be written as cos theta times cos theta over cos theta. And that can cancel, which actually leaves us. So I've zoomed right out, so you can't actually see anything. But basically, you get left with cos theta, because that's just this bit over here. And the good news is that is what the right-hand side was. So we get all that. Give me a score out of 10 about how you understood that one. How much of it you could follow. Okay. Should we do one more? Give me a thumbs up if you want to do one more, or a thumbs down if you'd rather go to start doing the quiz now. The quiz questions are probably a bit easier than these ones. We've got one more in us. Let me see those hands. Okay, we are going to do, for our last question of the day, we are going to do D. Sorry, not D, E. We're going to do E, this one over here. So can you start where you think you would start with this trig identity? Let's see what you can do with E. And then take a screenshot of the current one if you need to, because I'm going to rub this out in a moment. Okay. I definitely think I want to start with the left-hand side. And on the left-hand side, I also think I'm going to replace the tan to start with. But I mustn't forget about the cos beta that's just chilling out here. I think most of us would have done that, but that's where after that it gets a bit more exciting. So I'll give you some time, or I'll wait for some tips in the chat about what you would do next. What would you do next? If only the denominators could be the same, it would be so nice. Is there a technique we can use? I do believe there is. So what I did was I multiplied the first one by cos B and cos B, and then I multiplied the second one by sine B and sine B. And then what do we get left with? I'm going to write it nice and neatly. So sine B cos B is the denominator. And then on top, I'm going to have cos squared B plus sine squared B. And then the cos B is still just chilling outside there. Okay, what is my next step going to be? Ideas, people, ideas. Share the wisdom. Share your wisdom with the class. Sepang, what do you think? Gundo? Rilani, what do you think? What's standing out for you? Can you hear me?
So that
Yes.
for the numerator, the identity, I can turn it to 1, and then timing the cos b to cancel out the denominator's cos b.
Yeah, exactly. You nailed it. So basically, this is the same as 1. Okay, but the thing outside can be written as cos b over 1. And now the good news is that those can cancel, which leaves me with 1 over sine b, which is what I was hoping for. Yes, it is. Thank goodness. So that is the right-hand side, which I can see over here. So I would just say equals RHS. So today's lesson has been rather interesting. We've done some quite tough trig identity questions.